Welcome to Sabukaturi Unveiling TV. Here, we bring you a treasure trove of knowledge and wisdom, unveiling hidden truths and untold stories from various realms of exploration. From uncovering historical artifacts, to unraveling the mysteries of science, our channel is your gateway to enlightenment. Today, we're about to embark on an electrifying journey into the heart of a storm, where we'll unravel the mysteries of two of nature's most spectacular phenomena, lightning and thunder. Have you ever wondered how these awe-inspiring events are formed, or which comes first, the brilliant flash of light or the resonating roar? Today we'll answer these questions and more. We'll also explore the intriguing locations where lightning strikes most frequently, and discuss the effects of lightning on the human body. So, fasten your seatbelts, because today, we delve into the heart of the storm to understand how lightning and thunder come to be. Our journey begins with the formation of a storm, the cradle where lightning and thunder are born. Imagine a warm, sunny day. The ground heats up, warming the air above it. This warm air, lighter than its cool surroundings, begins to rise, creating an updraft. As the air ascends higher into the atmosphere, it cools down. This cooling causes the moisture within the air to condense, forming clouds. Now these aren't your ordinary fluffy white clouds that you might see on a calm day. These are towering cumulonimbus clouds, the harbingers of a storm. They can grow to be over 10 miles high, their tops stretching into the stratosphere. Inside these massive clouds, a fascinating process occurs. Tiny ice particles and water droplets collide with each other, creating a separation of electrical charges. The lighter, positively charged particles tend to rise to the top of the cloud, while the heavier, negatively charged particles sink to the bottom. This separation of charges sets up an electric field within the cloud. Meanwhile, the ground beneath the cloud becomes positively charged, creating a stark contrast with the negatively charged bottom of the cloud. This contrast intensifies the electric field, creating a tension that must be released. It's like a pressure cooker waiting to explode. The electrical tension builds and builds until it becomes too great. And then, in a brilliant flash of light, a bolt of lightning is born, a dazzling testament to the power of nature. But we're getting ahead of ourselves. That's a story for another scene. For now, let's linger in the suspense of the brewing storm. Let's marvel at the towering cumulonimbus cloud, pregnant with electrical energy, ready to give birth to lightning and thunder. As the storm brews, an incredible display of nature's power is about to unfold. Within the heart of the storm, a breathtaking spectacle takes center stage: the lightning. This dazzling wonder is not a random occurrence but a result of an intricate dance between electrical charges in the atmosphere. Let's take a closer look. Our story begins within a storm cloud where countless tiny ice particles are jostling and colliding with each other. As they collide, they create an electric charge. Just like in a battery, the negative charges accumulate at the bottom of the cloud, while the positive ones are drawn to the top. This sets the stage for a spectacular display. The negative charge at the bottom of the cloud is not content to stay put. It's constantly seeking a way to neutralize itself, and it does so by looking for positive charges. Where can it find this? Well, right beneath it, on the ground. As the negative charge builds up, it sends out a leader stroke, an invisible path of ionized air towards the positively charged Earth. Now here's where things get really interesting. As the leader stroke nears the ground, it attracts upward streamers, tendrils of positive charge reaching up from the ground. When one of these streamers meets the leader stroke, a connection is made. This is the moment we've been waiting for. Once this path is established, an electrical current surges along it, racing towards the ground at around a third of the speed of light. This rapid movement heats the surrounding air to an incredible 30,000 degrees Celsius, nearly 5 times hotter than the surface of the sun. It's this sudden heating that creates the brilliant flash we see as lightning. So, there you have it. The thrilling dance of charges that results in one of nature's most stunning spectacles. But remember, where there's lightning, thunder isn't far behind. In a flash of light, a bolt of lightning pierces the sky, but what about the thunderous applause that follows? Let's find out in our next scene. Once the lightning has made its grand entrance, the thunder isn't far behind. The spectacle of a storm is a grand play of nature, and after the lightning takes the stage, the thunder follows suit, creating a symphony of light and sound that leaves us in awe. But how does this happen? What causes the roar that often sends shivers down our spine? The answer lies in the intense heat generated by the lightning bolt. Imagine for a moment a lightning bolt is a superheated path of air, reaching temperatures of approximately 50,000 degrees Fahrenheit. That's hotter than the surface of the sun. This scorching heat causes the surrounding air to expand rapidly. Picture it as a balloon being inflated to its limit in a split second. This sudden expansion creates a shock wave that echoes through the atmosphere. The shock wave moves at the speed of sound, around 760 miles per hour. As it travels, the shock wave compresses and decompresses the air in its path, causing the molecules to vibrate. These vibrations produce the sound waves that reach our ears as the familiar rumble of thunder. However, the sound we hear isn't always a rumble. Depending on our distance from the lightning and the path the sound waves take to reach us, we may hear a sharp crack, a low growl, or a long rumble. Now, you might be wondering, if lightning and thunder are part of the same event, why do we see lightning before we hear thunder? The answer is simple. Light travels faster than sound. A flash of lightning reaches our eyes almost instantly, while the sound of thunder takes a little longer to travel the same distance. Therefore, it's clear that the lightning always strikes first, followed by the thunder. They are two sides of the same coin, two acts of the same play, bound together in the heart of the storm. And so, in the heart of the storm, lightning and thunder take their bow. Lightning is not just a spectacle to behold, it has powerful and often devastating effects. Imagine a tall building piercing the sky or a tree standing solitary in an open field. These structures, due to their height, are prime targets for lightning strikes. Lightning chooses the path of least resistance to reach the ground, and tall structures provide the perfect path. This is why it's not uncommon to see lightning rods atop skyscrapers, a safety measure to guide lightning safely to the ground, preventing potential fires or structural damage. Now let's shift our focus to the natural world. In forests, lightning strikes can spark wildfires, leading to massive destruction of habitat and life. But on the flip side, these fires can also serve as a natural part of the forest's renewal process, clearing out dead wood and making way for new growth. But what happens when lightning strikes a human being? The effects can be severe, even fatal. When lightning strikes, it can cause burns and other injuries due to the intense heat and electric shock. It may also lead to cardiac arrest, as the electrical current can disrupt the heart's rhythm. Survivors of lightning strikes often suffer from long-term effects, including muscle pain, memory loss, and even changes in personality. It's a stark reminder that nature's beauty can also be incredibly powerful and dangerous. As we delve deeper into the effects of lightning, it becomes clear that these electrifying spectacles are more than just a light show in the sky. They hold a massive amount of energy capable of causing significant damage and change, whether it's setting a forest ablaze or disrupting the rhythm of a human heart. In spite of the risks, the study of lightning continues to fascinate us. We're constantly learning more about this natural phenomenon, gaining insights that not only help us understand our world better, but also aid in developing measures to protect ourselves and our infrastructure from the devastating effects of a lightning strike. Indeed, the beauty and power of lightning hold a deadly potential. In the heart of the storm, we have witnessed the birth of lightning and thunder. We've unraveled the electrifying dance of charged particles, giving rise to the spectacular lightning bolts that light up our skies. These bolts, in turn, heat up the air around them, causing it to expand rapidly and create the thunderous roars we often associate with a storm's fury. We've also shed light on the striking truth that lightning does indeed strike before we hear thunder, a testament to the speed of light being faster than sound. We've pinpointed places where lightning is a frequent visitor, and delved into the potentially deadly effects of a lightning strike on the human body. As we bid farewell to the storm, we leave with a newfound appreciation for the power and beauty of nature's light and sound show. Thank you for joining us on this electrifying journey. Don't forget to subscribe to Sabukaturi Unveiling TV for more intriguing insights into the natural world around us.